He's associate professor at Institut Telecom in Rennes in France, and he's interested in large-scale networking and multimedia applications. And if you have ever wondered for your adaptive HTTP streaming applications, which rates you should actually support, then you should listen to him, because he's going to give us quite a few hints on how to do that. Please go ahead.
It's very good to motivate people. So since there is no time constraint, because of the last week I prepared 90 minutes, hope you don't mind. So it's a joint work with EPFL and two other colleagues from Telecom. We did not choose the green color. It's something funny for us. Talk about the video augmentation adaptive streaming. I don't have any slide about the fact that video is very important. We have all these kind of big services which makes our life easier. I just immediately go to for a slide on the system. So we basically, the goal of this slide is to just have the same kind of words for everybody and to motivate. So we talk about the content providers, which are the ones who produce the video. So it can be broadcasters, or it can be also users, the user-generated content. I mean, you don't really mind, it doesn't really mind. And there is in the content provider usually somewhere a server, and when they have to deal with delivery at large scale, they usually use a CDN. So in the case of Google, CDN and content providers are the same guys, but basically there are two different branches. And so there is the responsibility of the different servers that are in the process are a bit shared, but basically the ingest server usually prepares the videos. And then the origin server can also prepare videos sometimes. It depends on the CDN, on the implementation of the CDN. And then there is all the storage mechanism, the delivery mechanism that is on the CDN. At the end, you have all these devices. So basically, you all know that adaptive streaming means that one video stream input from the content providers is transformed into K different representations. So we'll talk about the representations for the different videos that are produced in the dash systems. And so if you look at the previous works, we see that there are many works on the adaptive video delivery, so many works on for live streaming, for building trees with the different representations, for in the case of VOD about how to replace video in the caches, how to make changes in the system, so including some works of mine. So there are many works in this direction. There are also many works on the client adaptation and on making sure that the last night video and the last night is properly set. A lot of works about how to adapt between the different representations. But there are fewer works on the preparation of the video in the case of adaptive streaming. So there are many works on preparation of a video when you have only one video, so you have to decide which rates and which quality. But when you have several videos to send, it's a little bit more empty. So we try to work on this stuff. So we kind of interview some content providers and we ask them, okay, what does it mean for you encoding a set of representations? How do you do that? And basically, the answer were quite obvious. It's that they have to decide how many representations they will produce for one video stream, and they have to also decide how many resolutions and what resolutions they will choose. And for each of the prepared representations, they have to decide the bit rate. And so, okay, we definitely agree with them. And we ask them, okay, so how do you do that? And they basically say, okay, we follow the recommendations from vendors, so basically others. Or when I ask why, I'm sure they say, yeah, I mean, at least it is on the website, at the top of the website, it looks serious. Okay, and some other guys are a little bit more into the proactive in the area, and they try to define their own set of representations on coding parameters. Typically, Netflix have their own stuff, but when we ask to the broadcasters, TV broadcasters in France, they say, okay, we do it a little bit like, yeah, why not 500 kilobits per second? That's good. So we say, okay, maybe we can here apply some optimization stuff. So this is why we are academics. So we have an objective with this study. It's to find the best set of representations for each video in the catalog of a video. So the best for us, it's the maximization of the quality of experience of the end users. So we can take Ali and his wife as a good example of a population. And we just want to maximize the sum of them. So we could have applied some kind of fairness into the stuff, but let's follow Ali's rules. And we have a constraint, which is the infrastructures. It is a constraint that has been raised by the content providers we met. Basically, they told us that their boss say, okay, I don't want to spend more than $1 million for the CDN for the month, so do what you want with your representations, but stop at that price. So we kind of applied this constraint in addition to the other constraints. And so what we did, and what is in the paper, is that we formulate an optimization problem. This is what we are good at. And then we try to answer the first question, which was, so how good are the recommendations from the vendors? How good they are in comparison to the optimal one? Since we can compute the optimal one on a static environment, we can decide, is it good or not? And then, since we will show that it's not that good, we try to determine some guidelines that could be used by the content providers for setting the parameters for the encoding of the encoders or the transcoder. So we start with a little bit of math, because the paper has some math. I reduce to the minimum. So basically what we have is that we have a catalog of movies, and we have to decide the resolution S and the bitrate R. Each user, so it is a point that is a little bit controversial, I guess. It's we decide that each user is associated with only one video resolution. So it means that if you start watching your movie 720p, you will stick to 720p and you will never change resolution. You will change bitrate, of course, if there are several representations and that resolutions, but we don't change resolution. So I don't know exactly if this is a one point that can be left for the future works. I don't know if in GPAT you can change of resolutions as often as you want, but something that is debatable. And we have one point which is interesting, that we want to measure the quality of experience, but we have several resolutions, so there is no comparison between the different resolutions. So we kind of normalized the satisfaction of user per resolution. Okay, so it means that we take an example for one video, and we compute the quality of experience with the VQM measures, and we normalize so that somebody who is watching the video with 360p typically is between something which is close to 0 to 1, exactly the same as for somebody with 720p, except that for this guy to be satisfied, you only need something like 3 megabits per second. So otherwise, for the 720p, you need something like 9 megabits per second. So basically, it means that if you are watching on a smartphone on a 360p, you don't need a lot of bitrate to be happy. So this is one point. I think that there are also many stuff to do on the how to switch from one resolution to another, and this is one of the problems. If we can allow switching from one resolution to another, we will always decide to take the lowest one. So as a constraint, so we just say that so we have this budget, CDN budget constraint that we transform into just a capacity. In fact, we have a capacity for the CDN, so we don't want the CDN to be overwhelmed for any reason. It can be storage, it can be bitrate, it can also be something which is monetary. And we also decided to have a constraint about the number of representations. Basically, we said, okay, we have some servers, and they have a limited CPU, so we don't want to produce 1,000 representations. We don't have the CPU for that. So we want to basically stick for our whole catalog, so not only for one video, but for the whole catalog of video. When we say, okay, we don't want to produce more than K representation. And we add something for that just this is the limitations of having a maximization objective in the optimization problem that some users can be not served at all just because some other users are super satisfied. So we say that the content providers, it's something that also seems to matter for them. They are able to serve a given ratio or fraction of percentage of clients. And then we got this kind of math. So I don't go into the details. I know my co-author wanted me to spend 22 minutes on that slide. 22 seconds, I think it's recommended. So first we try to compare the recommendations of users with the optimal solution. So we are able to compute for one solution the best. So we define some configurations. So obviously you can install everything and build your own configurations. We took 4 different videos. So one sport video, one cartoon, one movie, and one documentary. And this video will form the catalog. So if you want to, even if you are a content provider specialized into sports, you can just choose your sport video and that's it. But we try to make something which is a mix of everything. And we have a population of users, so we also have to decide what is the size of their screen display, what is their bandwidth. So of course you can also change if you are in a country with a better quality networks or lower. And we also had to define some settings, but it's just basically some settings. Then we use Cplex to compute from this set of data. Just it is an instance, it is one system, and we say, okay, what is the best set of representations for that maximize the quality of experience for the user, and then we just compare what is achieved by the recommendations of users, the recommendations of vendors. So we got Apple, Netflix, Microsoft. You can add the one you implement if you want. So I just show one slide with the results. There are many other slides many other figures in the papers. We just compare with Apple. So we add 4 videos. Apple say that you need 10 representations per videos. So with Apple, we have 40 representations that are produced. And we have here the quality average user satisfaction. So with Apple, you have something which is okay, which is 0.92. So it's something which is not bad. And we make vary the constraint on the number of representations for the optimal set. And so what we obtain is something which is a little bit better than Apple. So it means that after a while, you can have more representations. Basically, you are very close to the optimal, and you can be better than that. So if you just compare the difference, it's not that big. I mean, Apple is doing good job in terms of optimality. But what we observe is that we can do the same as Apple with almost half the number of representations. With only 5 representations per video, you can do approximately as good as Apple. So if you have some constraint in terms of server, CPU, in terms of number of representation, transcoding that you want to do, you can do something better. I don't say that it's easy to do that because it's one time, one shot. So it's just show that in fact there is a waste of CPU transcoding there. So I just show these slides for the comparison to the recommendations, and so I go to the guidelines. We have 5 guidelines. I just showed 2 of them in this presentation. Our presentation aims at you reading the paper, so just here for the trailer. So I defined many configurations where we try to push the system in every limit, okay? And so we try different kind of popularity of videos, different characteristics for the clients, and a lot of different constraints for the content providers, or the service providers. And we compute every time the optimal, and we try to look at how are the representations, what choices are the best for every configurations. And at the end, we identified some trends, and we identified something that could be transformed into guidelines. We tried to see these guidelines. So it just are 5 guidelines that if you are content providers, if you follow them, you might have good chances to increase the quality of experience for your user and to reduce your infrastructure cost. So basically, I present here one of the curves we have. It's one of the curves which is for kind of very well-balanced system. So it can be YouTube typically, where you have a lot of different videos. And what we show is that we show the number of representations, the average number of representations that are produced according to the different style of category of video. And we show how many representations are served for each of the resolution. And we had a K, which was something like approximately number 12 representations per user. And so what we can see is that there is a big difference between the number of representations that are produced for sports in comparison to the ones which are produced for cartoon. Almost 2 or 3 of them. So Ali will be happy. We have a lot of representation for him. I did not check on the results. So they are very happy for the results too. So I mean, what we was the most struck is the difference. Obviously it's harder to. We knew that it's harder to define code soccer game in comparison to cartoon. But at the end, the cartoon has almost no representations, only 1 or 2 per resolution, and it's enough to make the people happy. Although for the soccer, it's a little bit harder. And the second guideline that we have from this figure is also that there is a slide which is smaller in that case, but we have a slight emphasis on the largest resolutions. So it means that if you want to address people with smart TV, you have to provide more representations because the quality of experience is a little bit more distributed into the bitrate scope. So it means that you have to produce slightly more, but it's not like twice for the as a first guideline. It's something which is a little bit more subtle. So there are 3 other guidelines in the paper, so I invite you to go on that. And it's the conclusion, the last slide of the last talk of the last session. Read the paper. No, as a takeaway, I can just say that what we did is an optimality. I mean, guys like optimization will be happy with the integer linear program that we define. What main message that we have is that the recommendations from the vendors are not optimal. Of course, because it's only one recommendation for every service, but even for a very well-balanced service with different users, it's not optimal in terms of CPU and GPU recommendations. And we have some useful guidelines, and useful is what the component provider that we interviewed at least told us, but let's see if they apply our guidelines in the system. And for future works, we have a lot of possibility. I just wrote 2 of them, which were that we have to introduce more dynamic parameters in the system. So what we compute today is optimal for one shot, but we know that there will be variations into the bandwidth, there will be variations into the quality of experience for the different videos. So it could be possible to introduce a bit of this variation into the model. So here we can apply some techniques from the robust optimization, where we will introduce some probability of evolutions, and it might be useful if you want to define the optimal over a long period, over a longer period, not super long. Here. On the second point, that we have an optimization for that we see that there are big differences in the number of representations total on the catalog of videos. But we are considering services like Justin TV or Twitch TV. They have 6,000 video to transcode simultaneously. So if we apply our kind of techniques on this service providers, content providers, they could reduce the size of the data centers by 2 or 3. It can be a lot of money. So we want to transform this optimization stuff into something which can be applied at large scale, which means that the optimization is no longer possible because its Cplex will explode, and so we have to find some heuristics. Thank you. Thank you.
Right.
Actually, before leaving, I have just 2 comments. In Orange Labs, I'm doing my PhD. I mean, we carried out a lot of experiments about coding profiles. How many representations should we define, and we concluded that we, at maximum, it would be better to never exceed 5 profiles. Okay, whatever the category it moves. So, I mean, this is one of the conclusions we have found. Second remark is that it's about rate adaptation, and I mean the way how the client that is quality at maximum bandwidth and so on. There is always, in the works, research papers, you find always that authors try to push, try to define some sensitive algorithms in order to adapt as rapidly as possible to the bandwidth, and so this is what I find. But I mean, as an ISP, it is always good, to ensure some level of stability, so that to keep, stability during the user watches, the user when he watches the video. And this has this has some application also on caching infrastructure, CGNs, and so on. So, because ensuring some kind of stability, the operator may have some kind of control on what the client may watch or may request. So, giving client freedom to request whatever he wants. So basically, this may affect actually the efficiency of some major components such as caches and CDNs. So this is just one general remark to say that stability is so important for operators and CDN providers.
Yeah, I have a question. How did you model the requests of the users for a given bitrate? Do you have a model of the requests of the users?
Yeah, we have a distribution of bitrate users, and we kind of try to be as realistic as possible, but it's always hard in this stuff. But basically, the guys which have a smart HD TV, they are not connected in the network with 3G connection. So we have several types of network connections and several types of devices, and we make some probability just to build the population which look like reasonably realistic. And so we change also some of the parameters. Sometimes we say, okay, let's say that you are a content provider and you are specialized into UGC mobile services, so we put a lot of emphasis on the small devices, on the 3G network connections, and then we say, okay, let's say that we are Netflix. Netflix, they don't target smartphone, they target smart TV and fibers video, so we show that. Indeed, in that case, the recommendations of vendors can be very, very bad, because they are the recommendations from Apple, they are just generic, so they don't take into account this kind of things. But the point that we made is that it's even worse if you are a content provider which is specialized into cartoon. In that case, you have to change totally your way to do it. So this is one of the outcomes.
Thank you. Well, we have another question. Let's take it.
Very quick question. It's usually hard to convince the content provider or any company to use a context solution such like this, right? Do you think they are going to adopt your guidelines, or they won't?
The guidelines are not that complicated to implement. It just makes so they can use. It's not easy, but it's not something which is complicated. One of the guidelines is okay. According to your content, you have to change. It's maybe something that can be extracted from metadata of the video. Just some classified video catalog. You need to say, okay, this is a cartoon, this is an action movie. Let's do it. But when the first time we met the content providers, we formally the math, and they say, okay, let's do it. They say, okay, we never implement your kind of things. So we have to simplify the guidelines about.
Because for engineers, it's still extra work, right? So usually they have 20, they don't care if it's 20 or 40 representation, but they have fixed representation. I read the script.
Yeah, I know. Yeah, but it can be worth the price of coding new scripts.
All right. Thank you very much.